Today we shall continue with our study of trigonometry. We shall be looking at the trigonometric identities. Here are some trigonometric identities. The first identity here is tan theta, which is equal to sin theta all over cos theta. The second one is sin square theta plus cos square theta is always equal to 1. The third one is tan square theta plus 1 is equal to sec square theta. The fourth one is 1 plus cos square theta is equal to cosec squared theta. Number 5, A. Sin theta is equal to cos 90 minus theta, the complementary angle. Similarly, B. Cos theta is equal to sin 90 degrees minus theta. And then C, tan theta is equal to cot 90 minus theta. Number 6, compound angles. A, sin A plus B will be equal to sin A cos B plus cos A sin B. B, sin A minus B will be equal to sin A cos B minus cos A sin B. C, cos A plus B will be equal to cos A cos B minus sin A sin B. The little difference here you can see, where it is plus, it is minus at this other end of it. D, cos A minus B will be equal to cos A cos B plus sin A sin B. Then E, tangent. Tan A plus B is equal to tan A plus tan B all over 1 minus tan A times tan B. And the last one here, F, tan A minus B is equal to tan A minus tan B all over 1 plus tan A tan B. These are some of the identities we are going to use in solving problems in trigonometry. From the compound angles, we can also derive the multiple angles formula. A, sin 2A, which is equal to sin A plus A. Expanding it as we did before, we'll have sin A cos A plus cos A sin A. And of course, this means 2 sin A cos A. B, cos 2A, the same thing as cos A plus A. Expanding, we have cos A minus sin A sin A. And this will give you cos squared A minus sin squared A. One of the equations that counts the identity from base. Secondly, we can go further and expand this. Another identity that represents this is 1 minus sin squared A. Cos squared A is the same thing as 1 minus sin squared A. From the knowledge of sin squared A plus cos squared A is equal to 1. You remember that? So we have sin squared A plus cos squared A is equal to 1. And then you can now see that making cos squared A the subject of the formula, you have 1 minus sin squared A. That's why this is equal to this. Then minus sin squared A. Simplifying further, we have 1 minus 2 sin squared A. This is another identity. Then of course, this is also equal to 2 cos squared A minus 1, another identity, on the same cos 2A. So cos 2A has 3 identities. Please recognize them. C, tan 2A. Following the same procedure, we will resolve this to have 2 tan A all over 1 minus tan squared A. So these identities are from the compound angles, which is giving us the multiple angle formula. Let's take some examples. Number 1, simplify tan squared theta all over sec squared theta minus 1. Your solution. Using the identities, you have that tan squared theta all over sec squared theta minus 1 will become tan squared theta all over sec squared theta is the same thing as 1 plus tan squared theta, then minus 1. Now this will give you tan squared theta all over tan squared theta, because 1 minus 1 is 0, and the result of this is 1. So the answer to that problem is 1. Number 2, simplify sec square theta minus tan square theta all over sin square theta plus cos square theta. Your solution. We have that your sec square theta minus tan square theta all over your sin square theta plus cos square theta will be equal to your sec square theta is written as 1 plus tan square theta then minus tan square theta all over your sin square theta plus cos square theta is 1. Now this will give you 1 is there, tan square theta minus tan square theta is 0, so we have 1 over 1 and the value is equal to 1. Example number 3. If cos theta is equal to A all over B, find 1 plus tan square theta. Solution. Recall that 1 plus tan square theta is equal to sec square theta, and that means 1 all over cos square theta. So our cos theta is given to us as A over B. That becomes 1 all over A all over B all squared, which will give you B squared all over A squared, or B over A all squared. 4. Simplify sin 25 degrees over cos 65 degrees plus cos 40 degrees over sin 50 degrees. Our solution, you have here that sin 25 degrees all over cos 65 degrees plus cos 40 degrees all over sin 50 degrees. Now this will be equal to the complement of sin 25 degrees will be cos 90 minus 25. Everything here all over cos 65 plus, of course, the complement of this one will also be sin 90 minus 40. Everything here all over sin 50 degrees. Alright, we are all in degrees. Okay, so what happens if you subtract 25 from 90? You have cos 65 degrees all over cos 65 degrees. If you subtract this, you have 50 sin 50 degrees all over sin 50 degrees. Of course, this will divide this to give you 1. This will divide this to give you 1. Adding that together, you have 2 as the solution. Example number 5. Solve the equation sin 2s equal to cos s. Our solution, you have that your sin 2s is equal to cos s, and this is equal to sin 90 minus s. Combining this and this, you now have that your sine will cancel the sine, and you have 2s equal to 90 minus s. Then your 2s plus s collected like terms is equal to 90, giving you 3s is equal to 90, and your s is equal to 90 divided by 3, and that is equal to 30 degrees.